Section 12. Applications of chi-square distribution. Introduction. The chi-squared statistic plays an important role in text dealing with count data or enumeration data. This is the data required in dealing with problems where information is obtained by counting rather than measuring. In this study session, you will learn all the 5 important applications of x-squared text given in the last study session. Learning outcomes for study section 12. When you have studied this session, you should be able to test for independence of attributes, that is, analyze contingency tables, test for goodness of fit, apply Yates correction for continuity. Test for population variance and test for homogeneity. Contingency table. R by C contingency table the observed frequencies for two categorical variables arranged in R rows and C columns. The sum of all observed frequencies is n. The sample size the contingency table format is displayed as follows. Contingency table. Note that one. The variables A and B have been classified into mutually exclusive categories. Two. The values OIJ in row I and column J of the table show the frequency of observations falling in each joint category. I and J. 3. The row and column totals are the sums of the frequencies. Four. row and column totals has add up to a grand total n, which represents the sample size. 5. The expected frequency EIJ corresponding to the observed frequency in row I and G in each cell of the contingency table is calculated as follows. Test of independence of attributes. The test of independence uses the contingency table format and is also referred to as a contingency table test. The analysis of a two-way contingency table helps to answer the question whether two variables are related or independent of each other. Thus, the S-squared test statistic measures how much the observed frequencies differ from the expected frequency when variables are independent. Test procedure. Step 1. State the null and alternative hypothesis. If not, such that no relationship or association exists between two variables that is they are independent. H1 such that the relationship exists they are dependent. Step 2. Select a random sample and record the observed frequencies E values in each cell of the contingency table and calculate the row, column and grand total. Step 3. Calculate the expected frequencies E values for each cell. 4. To 2. Step 4. Compute the value of text statistics. Step 5. Calculate the degrees of freedom. S squared is equal to dx is equal to hard minus 1 in bracket, c minus 1 in bracket, where r is equal to number of rows and c is equal to number of columns. Step 6. Using a level of significance alpha and df, find the critical table value of s squared alpha. This value of s squared alpha corresponds to an area in the right tail of the distribution. Step 7. Compare the calculated and table values of x squared. Decide whether the variables are independent or not. Using the decision rule. Accept h naught if s squared calculated is less than its table value. S squared alpha r minus 1 in bracket c minus 1 in bracket. Otherwise we get h naught. Example 200 randomly selected adults were asked whether TV shows as a whole are primarily entertaining, educational, or waste of time. Only one answer could be chosen. The respondents were categorized by gender. Their responses are given in the following table. Is there any convincing evidence that there is a relationship between gender and opinion? In the population of interest. Solution. 1. Hypothesis. H naught opinion of adults is independent of gender or no relationship between the opinion of adults and gender. H1 such that opinion of adults is dependent on gender, or there is a relationship between the opinion of adults and gender. 2. Calculation of expected frequencies EIJ. U11 is equal to 44. E12 is equal to 22. E13 is equal to 44. E21 is equal to 36. E22 is equal to 18. E33 is equal to 36. 3. Compute the chi-square test statistic is equal to 11.129. 1. Compute the degrees of freedom. That is this df is equal to 2 minus 1 in bracket 3 3 minus 1 minus 1 minus 1 minus 1 minus 1 in bracket is equal to 2. Check the critical or table value. That is x squared 0.005 2 is equal to 5.99. 3. Decision. Since the calculated value is greater than the critical value, the null hypothesis is rejected. Hence, we conclude that the opinion of adults is dependent on gender. Goodness of fit test. On several occasions, a decision maker needs to understand whether an actual sample distribution matches or coincides with a known theoretical probability distribution, such as binomial, Poisson, normal, and so on. The S squared test for goodness of fit enables us to determine the extent to which theoretical probability distributions coincide with empirical sample distribution. To apply the test, a particular theoretical distribution is first hypothesized for a given population, and then the test is carried out to determine whether or not the sample data could have come from the population of interest with hypothesized theoretical distribution. The observed frequencies of values come from the sample, and the expected frequencies of values come from the theoretical hypothesized probability distribution. The goodness of fit now focuses on the differences between the observed values and the expected values. Large differences between the two distributions thrown out on the assumption that the hypothesized theoretical distribution is correct. On the other hand, small differences between the two distributions may be assumed to be resulting from sampling error. Example: a book has 700 pages. The number of pages with various numbers of misprint is recorded below. Number of misprints. Number of pages with misprint. Can a Poisson distribution be fitted to this data? Solution. 1. Hypothesis. H naught such that Poisson distribution fits the data. H1 such that Poisson distribution does not fit the data. Calculation of expected frequencies the number of pages in the book is 700, whereas the maximum possible number of misprint is only 5. Thus we apply Poisson probability distribution to calculate the expected number of misprint in each page of the book as follows. 1. Compute the value of is equal to 44.144.159. Note that observe frequencies less than 5 have been grouped to represent a single category before calculating the test statistics. 1. Compute the degrees of freedom. df is equal to n minus 1 is equal to 3 minus 1 is equal to 2. 2. Check the critical or table value that is s squared 0.05 comma 2 is equal to 5.99. 3. Decision. Since the calculated value is greater than the table value, the null hypothesis is rejected. Yates correction for continuity. The distribution of S squared test statistic is continuous, but the data under test is categorical, which is discrete. It obviously causes errors, but it is not serious unless we have one degree of freedom as in a 2 by 2 contingency table. To remove the probability of such errors occurring due to the effect of discrete data, we apply Yates correction for continuity. The correction factor suggested by Yates in case of a 2 by 2 contingency table is as follows. A. Decrease by half those cell frequencies which are greater than expected frequencies and increase by half those which are less than expected. This correction does not affect the row and column totals. For example, in a 2 by 2 contingency table where frequencies are arranged as follows. The value of S squared calculated from independent frequencies is given by this value of S squared is corrected as AD minus BC is greater than 0 and AD minus BC is less than 0. B. An alternative formula for calculating the S squared test statistic is as follows. Test for population variance. The assumption underlying the S squared test is that the population from which the samples are drawn is normally distributed. Let the variance of population be the null hypothesis is set up as where variance null is hypothesized value of variance. If a sample of size n is drawn from this normal population, then variance of sampling distribution of mean is given by. Consequently, the value of S squared test statistic is determined as with df is equal to n minus 1 degrees of freedom. Decision rule. Accept H0 if S squared calculated is less than its stable value S squared alpha over 2. Otherwise, reject H0. Confidence interval for variance. We can define 95%, 99% and so on. Confidence limits and intervals for S squared test statistic using table values of S squared. Such limit of confidence helps to estimate population standard deviation in form of sample standard deviation S with 1 minus alpha % confidence as follows. The subscript U and L stands for upper and lower tails proportion of area under S squared curve. For example, for a 95% confidence interval, the lowest 2.5% and the highest 25% of S squared distribution curve is excluded, leaving the middle 95% area. The S squared for upper 2.5% is equal to 0.025 area is obtained directly from standard S squared table. The obtained value of S squared for lower 2.5% is equal to 0.025 area. Look under the 0.975 column of S squared table for given DF because 1 minus 0.975 is equal to 0.025. Example: a random sample of size 25 from a population gives the sample standard deviation of 8.5. Test the hypothesis that the population standard deviation is 10. Study the solution below. Decision: since the calculated S squared is less than its critical value, the null hypothesis is accepted. Thus, we conclude that the population variance is 10. Test of homogeneity. The test for homogeneity is useful in a case when we intend to verify whether several populations are homogeneous with respect to some characteristic of interest. The null hypothesis specifies that several populations are homogeneous with respect to a characteristic. This test is different from the test of independence on account of the following reasons. 1. Instead of knowing whether two attributes are independent or not, we may like to know whether different samples come from the same population. 2. Instead of taking only one sample, for this test, 2 or more independent samples are drawn from each population. 3. When the characteristic to be compared consists of two categories, this test is similar to the test of hypothesis of difference between two populations means of proportions. To apply this test, random sample is drawn from each population and then in each sample The proportion falling into each category or stratum is determined. The sample data is obtained and is arranged in a contingency table. The procedure for testing the hypothesis is the same as discussed for test of independence. Summary. In this study session, you have learned the following. 1. Contingency table. A R by C contingency table shows the observed frequency for two categorical variables arranged in R rows and C columns. 2. Expected value Eij, E is equal to 3. Test of independence of attributes and goodness of fit text. Test statistic. 4. Yates correction factor for a 2 by 2 contingency table. And